Okay, so I did add some graphing problems to your homework for the weekend. So I just wanted to show you how these work. They're actually pretty easy. I thought they were sometimes graphing on MyMathLab is a hassle, but they're actually quite pretty simple. So let me find one that's okay. So in this problem, the amplitude is 5. That was easy. The period is, remember, it's going to be 2 pi divided by this number. So 2 pi divided by 1/4 is 2 pi times 4. That's 8 pi. By the way, I just typed in pi and the computer knows it's pi. Phase shift left, right, there's no number added to or subtracted from x. So the phase shift, there is none. So we put 0. And now we're going to graph it. Okay, so I'm going to click to enlarge and I get this. And basically, you don't really have to like draw the graph. You just kind of type this stuff in again, and it graphs it for you for the most part. So I know I'm dealing with the sine curve. Check the sine curve. Where is it? Cosine, sine. Click the graph, choose a tool. There it is, okay. Just as I was saying, it's really simple. I had some issues there. But basically, I click on the sine curve, and then I click on the graph. I guess I'm going to try and find my first point. So this is 5 sine 1/4. So it's going to start at 0, 0. Okay, so that's good and go up. So I like that. Now I got to adjust the amplitude. The amplitude's 5. Right, so you're not really, you just click the graph basically. I guess you want to click, let me see. If I click a point that's not on the graph, let's see what happens. So let's say I think this guy starts at pi over 2, which I can't even do. It's kind of helping me out, I think. Let's start at 2 pi. There you go. It is really helping me out. I can't even start somewhere else, right? If I'm saying, okay, sine curve, click up here. It's just gonna do the regular sine curve. That's the y equals sine x, and then you're gonna adjust it. So really, you're not graphing like some of these. You can kind of draw the graph on here. So you're just gonna type in all your information. Period here we decided was 8 pi. Vertical translation, there's none. If we moved it up, we go up. Whatever, up 5. As that said, plus 6 at the end, we put a 6 here. There's no phase shift. There's no negative, so we're not reflecting. You shouldn't have to do any reflection over the y-axis if you take care of the odd function, the odd property. If you have a negative input, that's a reflection around y, but we can apply our odd property, then we don't ever have to worry about it. For cosine, there won't be a reflection over x. If there's a negative in there, right? If it's given, it would reflect over x. So really what I'm trying to say is if you deal with the odd properties like we did in class, you only have to really deal with the reflection over x if you end up with a negative out front. Okay, so that's our graph, I believe. Let's see if we got it right. Uh-oh, you've not completed the question you received for credit. Show you one of these questions. No. What did I do? What did I miss here? What did we not do? 5, 8 pi. Click the graph using the function for any answer box shown. Grapher, type exact answer, word pi. I don't know. I think we did everything. Let's see what happens. Maybe it's just because I was in preview mode. I don't know. I think we did everything. But go ahead and play. Remember, you get 3 attempts per problem. If you have that issue that I just had, let me know because I feel like I did everything. Okay, so you have a bunch of graphing. They shouldn't be too bad. Remember, in class and on a test, I'll ask you to do that all by hand. What else I want to show you in this video? I want to show you something from 7.1, an intro, because I'm going to put a couple of these on your homework as well, and just the Pythagorean identity. Identities, I should say, because there's more than one. I'll show you 3 of them. Identities. So here's your unit circle. It's a real easy proof. We love easy proofs. Let me pick any point on my unit circle. That is the point x, y. Okay. So we know, because this is a unit circle that has a radius 1, that the equation of that circle is x squared plus y squared equals 1. Okay. When we do proofs, we use stuff we already know to prove new stuff. The new stuff is we decided this x value is the cosine of theta. And we decided that the y value is the sine of theta. So I can do a quick substitution here and replace y with sine theta. And I end up with my Pythagorean identity. That's it. That's the proof. That is, if you believe that the equation of the circle is x squared plus y squared equals 1, then, and we also understand that x is just the cosine value on the unit circle, and y is the sine value. And I'm just going to put sine first because that's usually how it's written for some reason. Then I end up with my Pythagorean identity. Think about that. Cosine squared plus sine squared equals 1, or sine squared plus cosine squared equals 1. Does that work for any value? Well, it should. Right? And that can be a negative value. If I'm in quadrant 2, cosine is negative, but when I square it, it's positive cosine squared. If I just pick any angle, let's pick 2 pi over 3. Does that work? Everyone knows that the cosine of 2 pi over 3 is negative 1/2, and that the sine of 2 pi over 3 is root 3 over 2. So we can do a check of our proof. Does 1/2 squared plus root 3 over 2 squared equal 1? Well, it should. 1/2 times 1/2 is a fourth. Root 3 squared is 3. 2 squared is 4. 1/4 plus 3/4 equals 1. Okay, that's not the proof. This is the proof, but we could try it for any one and it should work. Okay, so that is one of our identities. Cosine squared plus sine. Maybe it is cosine squared usually written first. It doesn't matter. Sine squared plus cosine squared equals 1. That is equation 1. Now, I'm going to quickly get 2 more real easily. Watch this. You're going to love this. I can do some identities that we know. All right, here's the identities that I'm working with now. You know that 1 over sine theta is the cosecant of theta. You know that 1 over the cosine of theta is the secant of theta. And you also know that the sine over the cosine is the tangent of theta. And you know that the reciprocal, and I don't know if we saw this one in class, but you know this has to be true, that the cosine over the sine, the reciprocal of the tangent, has to be the cotangent. Okay, so here in this box are identities we've already learned. So now I can add 1 to that, 1 Pythagorean, which we just learned. And now I'm going to have 2 more Pythagoreans. So watch what happens here. I'm just going to divide everything by sine squared theta. And what do I get? Sine squared over sine squared is 1. Cosine over sine is cotangent. So if that's squared, then that's the cotangent squared. And 1 over sine squared, we know, 1 over sine theta is cosecant theta. So 1 over sine squared is cosecant squared theta. Identity 2. So there's identity 1 before I divided. Here's identity 2. All right, let's do another one. I'm going to start again with the original. And I'm going to divide everything by, instead of sine squared, cosine squared. I'll get another one. You can see these all the time. These are really common. Sine squared over cosine squared is tangent squared. Cosine squared divided by cosine squared is 1. And 1 divided by cosine squared is secant squared. 3 Pythagorean identities. Okay? And for your homework, I'm just going to ask you to do a little bit with these. What am I going to ask you to do? Well, if you look at the problems, you'll see stuff like this. It'll just ask you to do some algebra and apply identities. For example, you're going to see a problem on your homework that says simplify, and it'll go like this. Cosine squared minus sine squared. No, not that. It'll go like this. Cosine to the 4th minus sine to the fourth theta. And these are fun. These are we get to be a little creative. If it just says simplify, so how can I make that simpler? Well, you got to think about what you can do. And for right now, we're just going to be factoring and multiplying. Okay, so when you see these on the homework from 7-1, think factor and multiply. So let's factor. This is the difference of squares. I mean, I know they're to the fourth, but fourth degrees are squares. So see if you like this. The difference of squares means 2 conjugates. Okay, so that's how that factors as the difference of squares. Because if you were to FOIL that out, you get what you started with. And now for the fun part. This like I said, it's going to happen all the time. This guy will show up when we're doing these kinds of problems. That's 1. That is 1. Cosine squared theta plus sine squared theta is always 1. So how about that? The cosine to the fourth theta minus sine to the fourth theta is the same as cosine squared minus sine squared. Let's see. What else are we going to have you do on the homework? Stuff like... what else will you see? Well, let's take a look at it. So you're not too surprised since we didn't go over this in class. Let me pull up your homework and we'll do one more. And then this video will be over. 28 questions. Sounds like a lot, but these shouldn't really take you too long. I don't think. I'll even do one for you. Cotan b minus, okay, so in this case we're going to multiply. Okay, so let's multiply, see what happens. Cotan b minus 1 squared. How will that simplify? Cotan b minus cotan beta minus 1 quantity squared. Simplify it. Well, but that, by the way, that's not cotan squared b minus 1 plus 1, right? You have to FOIL. Don't forget that. That'd be the common mistake, is just to square each of those, and that would be your answer. Make sure if you ever square a binomial, you do that. Not conjugates, right? It just means that says squared, so there I just repeat the factor. And I get cotan squared beta minus cotan beta minus cotan beta, that one, plus 1. All right, and then you're looking for your identity. Find your identity. Get used to this. Like I said, there's a lot. That should jump out at you. Well, maybe not yet because we haven't seen a whole bunch of it. But cotan squared plus 1, see if I can find it, is equal to cosecant squared theta. And that's what you're doing in the homework. You're just trying to simplify these by finding these Pythagorean identities somewhere in the problem. So you do a little bit of algebra, and then you find your identity. And then that was cosecant squared beta, and there's 2 of those. And that's all you can do with it. And that would be the correct answer. All right, so that's your homework for the weekend. You've already watched the video, so now go ahead and try that homework. And let me know if there's any issues with any of it. Send me questions.